Welcome to this Junior Cycle Higher Level Maths Revision video. In this video, we're going to focus on quadratic roots. So as part of this, we're going to look at how to find the roots of a quadratic equation. We're going to work backwards to find the quadratic equation when we're given the roots. We're going to look at a shortcut to do this, specifically for quadratic trinomials. And finally, finding the equation of a quadratic given a graph.
So just to do a little bit of background about the roots, if you're asked to get the roots of an equation, it is the exact same question as asking you to solve the equation. When we're working in algebra, it's more likely that we see the question solve. When we're working in functions or with graphs, it's more likely that we'll see roots of the equation. From the picture here on our right, the roots are where the graph, in this case a positive quadratic, cross the x-axis. So we can see that there are 2 points where that happens, where x equals 3 and x equals minus 2. These could also be called the x-intercepts, or they may ask you specifically for the points where the graph cuts the x-axis. Do watch out for the difference in questions, because if they ask us for points, our answer should be in the form of points, which should be 3, 0 and minus 2, 0.
Example 1. We're going to focus on finding the roots of a quadratic function. In this question, we've been given f of x is equal to 2x squared plus x minus 6, and we've been asked to solve when f of x equals 0. So we take our f of x, which is 2x squared, plus x minus 6, that's f of x, and we let that equal 0. So this is just another way that we can be asked to solve a quadratic equation. Don't be put off by the fact that they're using function notation and the way that it's asked. So we can use a few different methods to do this. You can use factorization or minus b. For the junior cycle exam, you will be hinted at if minus b is required. Remember, minus b can always be used. I'm going to use guide number. You can also use trial and error factorization, but I think guide number suits this best. So the guide number is the first term, or the coefficient of that first term, by the last term. So the guide number here is minus 12. And we're trying to find the factors of minus 12 that will add to give me a plus 1. Remember, an x means 1x. So the best thing we can do is list them all through. If you're struggling, we have 1 and 12, we have 2 and 6, we have 3 and 4. Minus means they'll have different signs. It is best for us to have 3 and 4. We want it to be a positive one, so plus 4 minus 3. If you can spot that straight away, you don't need to list out all of your factors, but just be really, really careful. The signs can cause a bit of problems here. So what we do is we replace the middle term, that 1x, with minus 3x plus 4x. Remember, the reason we're doing this is to make it 4 terms, so now we can do grouping. So what is common in the first 2 terms? That's x, leaving me with 2x minus 3. Always take the sign of the fourth term using this method. So plus and common, there is a 2, leaving us with 2x minus 3, and that all equals 0. We now want to just double check that our brackets are the same. They are. And then we combine the other 2 terms. So we get x plus 3 equals 0. Using the zero product property, we can say that if 2 things are multiplied and give us an answer of 0, then either the first thing must be 0, so the 2x minus 3 is 0, or the second thing, or the second bracket in this case, equals 0. Here we're going to add a 3 to both sides. That gives us 2x equals 3. And to finish, we divide both sides by 2. So x equals, you can say 3 over 2, or if you prefer, 1.5. For the second one, we take away a 3 from both sides, and we're left with x equals minus 3. Now, this question didn't ask, but I think it's really important that we understand what this means. So we're going to do a little bit of a sketch. I know it's a positive quadratic because looking at this 2x squared, so always the x squared term, it is positive, so therefore it is a positive quadratic. We then have two roots, a positive root and a negative root. The positive root here is 1.5 or 3 over 2, and the negative root is minus 3. There's one other piece of information that we have that we can fill in, and that is this constant here, minus 6, tells us that the y-intercept here is minus 6. It's really important that you understand how these questions relate with the graphs, because often what happens is students can do the algebra side of it, but then when it comes to graphs, they really struggle. So if you can make that connection all the time, then you'll find the graph questions much easier. Example 2, another question where we're asked to find the roots of this function. Again, they've given this in function notation. G of x equals x squared minus 6x plus 9. Remember, function notation, it's just giving a name to the function. G is its name. G of x is another way to say y, but if we had multiple functions and they were all called y, we wouldn't be able to tell them apart. So this is why we're given the actual name of G. So don't get put off by this function notation. G of x equals 0, but G of x is x squared minus 6x plus 9, and we allow that equals 0. Again, we're just being asked to solve this quadratic equation. For this question, again, we can use factorization or we can use the minus b, but there's no indication that minus b is required. So I'm going to use factorization. Because it starts with an x squared, i.e. the leading coefficient is 1. That is that the number here is a 1. I wouldn't write it because we don't need to, but because that's a 1, we can use the shortcut for factorization. Now, I like this, but if you are finding it a struggle to remember all the different things, guide number will always work. So it starts the same as guide number, but because the coefficient is 1, we end up with a plus 9 as my guide number. We now are looking for the factors of 9 that give us minus 6. Since the plus, they're both going to have the same signs, and it's going to be minus 3, minus 3. Now, instead of doing this out in full, the shortcut tells me, because it's an x squared, I can simply open my two brackets, and in my brackets, x goes at the start of each, and then my answer over here, the 2 minus 3's, go into our bracket here. So that's the shortcut. You'll get exactly the same answer if you work that guide number out in full. We now have zero product property to say that each of these factors, x minus 3, could equal 0. Notice that both factors are the same. So we get x minus 3 equals 0 and x minus 3 equals 0. We can add a 3 to both sides. And when we do that, we get x equals 3 and x equals 3. So we get two answers, but they're both the same. That's kind of interesting. Let's sketch it and talk a bit more about this. So it is a positive quadratic because x squared here, I know that that x squared means that it is a positive x squared, which means it's a positive quadratic. The roots are both the same. So usually we get something like this, which gives me two different roots, which is not the case in this question because we only have one root, and that root is 3. So how does this look? Well, this is what our graph ends up looking like. I'm going to just try to do my best with a bit of a sketch here, and it comes back up. So when we have two roots that are the same, like this, the graph doesn't go through the x-axis, it bounces off it. So this kind of sketch where we're not going through the x-axis, we're not getting two different or two distinct routes, we're only getting one. It's because it gets to the axis, the x-axis. So just to keep us in line, I'll give you x and y. It gets to the x-axis, it doesn't go through and it comes back up. But by its definition, quadratics will always have two roots, but in this case, they both are the same. We are going to then put in one other point, and that is the constant here at the end, and the constant is here, which is 9. This is a very special type of quadratic, and it's a perfect square. And the reason for that is, if we look at this line here, the two factors are x minus 3 by x minus 3. So this could be written as x minus 3 squared. So it is a perfect square because it can be written as something squared. And when we have that, we end up with this quadratic shape that doesn't go through the x-axis. You don't have to worry too much about that. You do need to understand how you would sketch it or how to recognize it, but we'll do a lot more with those perfect squares when you get into Leaving Cert. Example 3, finding the roots of a quadratic function. Again, they've given us a function h of x. Remember, h is just its name. It is x squared minus 2, and they want us to solve h of x equals 0. So x squared minus 2x equals 0. Now, this kind of question often confuses students because they think, is this a real quadratic? And yes, it is a real quadratic because what makes a function a quadratic is the fact that it has an x squared, and this has an x squared. What I would say is it's not a quadratic trinomial, so it doesn't have the 3 terms that we're used to. So it doesn't look like a real quadratic, but it is. It's just not a quadratic trinomial. So it has the x squared term, it has the x term, but it's missing the constant. Now, sometimes when students get to this point, especially in the higher level course, they get confused and think, I don't know how to solve this. In theory, yes, you could use minus b and the constant would be 0. However, the easiest way to do this is factorization. And you think, well, how do I do guide number on this? The answer is you don't. Think of our other types of factorization. Remember, we have 4 types of factorization. We have highest common factor, we have grouping, we have quadratic trinomials, i.e. guide number, or you might do trial and error, and then difference of 2 squares. So when we have a quadratic that's a bit different, so i.e. not a quadratic trinomial, chances are we're going to have to use highest common factor or difference of 2 squares. So for this question here, this is highest common factor. So x is common, leaving us with an x minus 2, and that equals 0. How easy was that? Zero product property, x could be 0, or x plus 2 it could be 0. If x plus 2 could be 0, we're going to figure out with another step by taking away 2 from both sides that x is actually minus 2. Oh, I've made a bit of a mistake here. Apologies. So this actually should be x minus 2 equals 0. I should add a 2 to both sides. And then my final answer is x equals 2. Yep. Apologies. So that's 0, and then I add a 2 to both sides. So it's just that bracket equals 0, giving me a final answer of x equals 2. So let's sketch this one out. So even though it's not a quadratic trinomial, it will still look like a quadratic. It has an x squared here, which means it is a positive x squared, which means this is a positive quadratic. It's going to have 2 roots. The roots are at 0 and 2, so it's going to look like this. So one of my roots is 0, the other is 2. It has no constant, so it's like there's a plus 0 here at the end, and that is exactly where it goes through the y-axis. So when we have these special types of quadratic, so where it's not quadratic trinomial, it will still look like any other quadratic, However, it does go through this special point here, which is the origin.
So if we are using the roots of the equation to find the equation, we first must make sure we are 100% with how factorization works. So I'm going to work through the factorization method of solving a quadratic equation. So a quadratic equation here is given as 2x squared minus 9x minus 5 equals 0. From this we get a guide number of minus 10. We get that by multiplying the first coefficient, 2, by the last constant, which is minus 5. That sign is really important. The negative means that whatever our factors are going to have different signs. So working that through, if I multiply 1 by 10 and they have different signs, I can work it through so I get my negative 9. So my plus 1 multiplied by minus 10 does give me minus 10, and plus 1 minus 10 equals minus 9. So our method here is we're trying to work out how can I split this minus 9x into two terms, which I will then which then means I can use grouping. So I'll have 4 terms, so I can use grouping. We've split that minus 9x into plus 1x minus 10x. Sometimes when you're doing factorization, you can get a little bit caught up, but I would definitely advise you to double check. Does plus 1x minus 10x give us minus 9x, and really focus in on those signs. In this case it does, so my next step is to factorize using grouping. So I group the first two terms and the second two terms, and then I get x times 2x plus 1 minus 5 times 2x plus 1 equals 0. At this point your check should be that both brackets are the same. If both brackets aren't the same, something has gone wrong. It could be as simple as you haven't taken out the highest common factor, you've just taken out a common factor, or it could be something got to do with how you factorize that guide number. Bringing these together, we get x minus 5 and 2x plus 1 equals 0. What's important to note here is this line here gives us factors. So these brackets, these are our factors. If the question was to simply factorize a quadratic trinomial, this is the point where we'd stop. But we're asking in this question to solve the quadratic equation, so we've one more step to go. So we take each of our factors, or each of our brackets, and we let each factor equal 0, and we solve for x. So we rearrange it to get x equals 5 and x equals a half. At this point, we have the roots. So that is our process. And what we're going to see now, as we work with the roots of any equation, but in particular quadratic, we're going to do this exact method, but work through it backwards. So just an overview of what's happened. We start with the equation. We break it into smaller pieces that multiply together. There are factors, and we let each factor equal 0 to then get our roots. So when we use the roots to build the equation, we're going to work backwards. So we start with the roots, we then get the roots into factors, we then get the factors into an equation. So if we let each factor equal 0, the opposite will be true. We're going to rearrange our roots so that it's something equals 0, which will create our factors. And if we were factorizing our equation to get factors, the opposite of factorization is multiplication. So let's see this example in action. Form the quadratic equation with the following roots, 4 and minus 2. So the first step in any question is to write the roots like we would see it at the end of a question asking us to solve. And that is x equals 4, x equals minus 2. Let's keep track of what we have. These are our roots. So remember, we're working backwards. So what we want is to get this equal to 0. So I'm going to subtract a 4 from both sides here. So I get x minus 4 equals 0. Here I get x plus 2 equals 0. So remember, we let each of those factors equal 0, so by that logic, we must have had a factor which was x minus 4, and we must have had a factor that was x plus 2, and they were both multiplying to give us 0. So at this line here, this is our factors. Now, if I want to multiply out that bracket, we split the first bracket, which is x times x plus 2 minus 4 times x plus 2. That equals 0. Multiplying that out, I get x squared plus 2x minus 4x minus 8 equals 0. And we get x squared minus 2x minus 8 equals 0. And we are back to our equation. So hopefully you can see at this point that it is the exact opposite to if we were using guide number to factorize and then solve.
So we can do the same thing but using a shortcut. And this shortcut is specifically for quadratics. We're not too worried about this for junior cycle because we only deal with quadratics. But as you move beyond that for leaving cert, we will look at cubics and degree 4, degree 5 and so on. This shortcut is specifically for quadratics. It is not something that I would suggest you use unless you're really good at learning off your formula. This is not in the log tables. This formula is something you'll need to know off by heart if you want to use it. It is shorter, but trade-off is, yes, you have to learn it. I think it's important for you to see it. If you use the shortcut for factorization or if you use trial and error, this will probably make a bit more sense. So our formula is, and it's given in this box here, x squared minus the sum of the roots x plus product of the roots equals 0. So two really important words. Sum is where we add and product is when we multiply. So we have two roots here, and that is 3 and minus 5. So if we do the sum of the roots, it's going to be 3 plus minus 5, which gives us minus 2. The product of the roots is going to be 3 by minus 5, which is minus 15. Then our formula is x squared minus, instead of the sum of the roots, we're putting in minus 2. Make sure you use your brackets. And that is followed by an x plus, and then the product of the roots, minus 15 equals 0. Tidying this up gives us x squared plus 2x minus 15 equals 0. And that's our answer. So it is a lot shorter, but remember you need to know that formula if you want to use this method. So our final example is using a graph to form the quadratic equation. There is nothing different about this, just the way we're presented with the roots themselves. So looking at the graph, we can spot that there are two roots, and the roots are x equals minus 2 and x equals 3. I'm going to use the longer method because I think it's nicer. Remember here we have our roots. We then want to change these roots into factors. To do that, we get a 0 on the right hand side. So here we're going to add 2 to both sides. And we get x plus 2 equals 0. Here we take away 3 from both sides. And we get minus 3 then equals 0. The two things equal 0 are our factors, so that's x plus 2 by x minus 3. They are factors. Since they both equal 0, multiplying them together will also give us 0. We then want to expand those two brackets to bring us back to our equation. So I'm going to use split the brackets. So x bracket x minus 3 plus 2 times x minus 3 equals 0. X squared minus 3x plus 2x minus 6 equals 0. Tidying it up by adding our like terms. X squared minus x minus 6 equals 0. Now, there is one additional step that you need to do at the end of this when we're given a graph as opposed to the roots themselves. Because we're given a graph, we're given one other piece of information, and that is the y-intercept. So it's important that we double check that our answer makes sense compared to the graph. So when I look at my answer, my constant here is a minus 6, which agrees with the y-intercept on my graph, so all looks okay. At junior cycle, we wouldn't expect them not to agree, but it is an important check to do.